Thank you all for being here today, and thanks to my panelists for coming in. We're super excited to have teams from Reflection, Poolside, Vercel, and Cognition here. These are sort of companies that are really pushing the forefront of what's happening in software development today. But Ionis, why don't I start with you and we'll go down the row. I would love you to introduce yourself and talk a little bit about what your company does and where you think we are in the Gen AI hype cycle today.
Yeah, great. Thank you so much. I'm Yanis. I'm the CTO and co-founder of Reflection. At Reflection, we are building super intelligent coding agents. So these are agents that can complete tasks autonomously, end-to-end, for engineering workflows. I believe that there's a question of whether we are in an inflection point or whether there won't be as much growth going forward. I think the way that we should be thinking the problem is that it's not. Some people think that it's it's the year of agents. I think it's the decade of agents. I think that we will see a lot of more agents just really changing the economy and the way that we do things and the way that engineering teams operate, how software is being built, and also how processes within enterprises happen. So I think in a way we are trying to reinvent the economy and just rethink the processes with an AI-first approach. So it's going to be a really interesting 10 years.
Amazing.
Hey everybody, I'm Jason. One of the co-founders at Poolside. We build foundation models from scratch for software, as well as a full stack application, meaning on top of it, it's API endpoint, obviously, so you can embed it inside your organization. IDE integrations, VS Code, Eclipse, IntelliJ, Visual Studio, and agents and agent frameworks. We're mostly built at the moment for what you might consider super secret, high secure, high compliant environments. So think government defense, public sector, banks, things of that nature. Man, hype cycle, it's hard to say because I don't think we've ever seen a wave that looks like this in terms of investment, in terms of recognition of importance, but at the same time, there's a lot of bullshit out there. And there's a lot of people who are just spewing stuff about what is and what isn't important. And so it's hard. How do you quantify what that looks like? But I fundamentally believe that neural networks are the most important digital technology of our lifetime, and they're going to rewrite most of everything that we do.
Hey, my name is Malte. I'm the CTO of Vercel. So Vercel traditionally has been building, on one hand, frameworks for software engineers to build applications, and then the infrastructure for running them in production. And as the AI wave has been kind of rolling over all of us, we've managed to kind of really transform that business into one that builds frameworks for building AI applications and agentic applications. We've heard about those already, which are really kind of changing not just how we write software, but also the kind of software we can write has extended to a larger set of software that's actually very valuable. And then the other thing is that we're building a tool called V0, which is used by non-software engineering professionals to build software from scratch. You've probably heard the word vibe coding. It's kind of the general category. But what we've been really seeing is that people who are adjacent to software engineering can now build applications. And so rather than coming to a meeting with a document and everyone has to have their own thing in their head of okay, this is what you mean, this is what you mean. No, you come with a working application and that's where you start the project. And then you kind of just think about how to go into production. But this entire life cycle of software development is kind of compressed into something that someone who is not themselves a software engineer can do.
Hey everyone, I'm Russell Kaplan, president at Cognition. We're the makers of Devin, the AI software engineer. And we started as a research lab in late 2023. And at some point we made enough research progress, we decided we should actually ship this as a product. And that became Devin, which we launched sort of early last year. And it's been amazing to see the growth in software engineering and AI, and particularly this shift from sort of co-pilots to co-workers. And that's kind of how a lot of our customers use Devin. And Blaze, on your question, I think we are still very, very early relative to where we're going to be when it comes to the deployment of these autonomous AI systems, especially in software engineering first, but then in everything. And one way we measure it is we look at, of all the work Devin is doing, how much of this work is work that would have otherwise been done by a person, or would it just have not gotten done at all? And the large majority of the work, it's pulling in things from the backlog or the wish list that probably wouldn't have even been done in the first place. And the whole history of software engineering is a history of higher and higher level abstractions from punch cards to assembly to COBOL to Java. And now we think of AI as the next step on this existing ladder. And we think there's going to be way, way more software engineering done in the future than ever before.
Yeah, we couldn't agree more. And we always talk about how everything starts at code, and we're seeing these transformative things of changing the way that people are working, first with software engineers, and then we get excited to see it move into other markets. But Jason, my first question's for you. Like, we've spoken a lot in the past, and we invest in your company and super excited about how software is just completely changed with AI. Can you walk us through what that actually looks like and how the software development lifecycle and tooling today is so different to the tools in the past?
Sure. So I think it's important to step back for a second and even just say what is out there and what exists. So the software development lifecycle, if you're not familiar, is essentially, when it boils down to it, it's just a series of steps that happen inside an organization or a team to guarantee a set of things. So you want to say that it goes from step A to step B to step C to step D and then to production. And inside of that, a whole bunch of things are meant to happen, whether you're building the software and testing it, whether you're making sure that a certain set of quality controls are being done. And we've built those over the decades, and we've changed a lot of the tooling. Part of what is happening at the moment here is that developers are looking at the aspect of software itself as an adjacency to code. Developers in their IDE are interacting with AI against the code itself or the code base. But what we're starting to see, and we're starting to see this particularly with agents as they extend out, is that much more of that SDLC, the software development lifecycle itself, is starting to get done by AI. Whether it's an agent that sits inside of a build system and automatically tries to fix what's happening in there and submits a PR back, even if it's a human to review it. But a lot more of those sorts of things are happening. I like Russell's framing of this is sometimes work that wouldn't have gotten done starts to get done. And I think that's an important aspect of things. And the way I like to think about this is, people ask all the time, what does software look like in 5 years or in 10 years? Well, obviously it's going to look very different, but it belies maybe a misunderstanding about what software is. Software is a massive umbrella category that involves things on one side of the fence, from figuring out what to build, what it's going to look like, what the documentation is, what the unit tests are, what the build system is, what the compliance checks and controls are, whether it's ready to go to production, monitoring and alerting and logging in production. There's a host of things. And when we boil it all down to source code, is a mistake. And so I think the entire SDLC is getting rewritten on the fly over the next 5 years. And most of the software development lifecycle itself is going to collapse into the models and the agents.
Yeah, super helpful and amazing to get that context. Russell, my next one's for you. You guys kind of were the first company that kicked off the agent craze in coding and got a lot of buzz for what you built with Devin. Can you talk to us about where you think we're at in autonomy, or in getting to AGI today, and what you think the hard engineering challenges that still face us to get to AGI, the promise that AI has?
Definitely. And we think about this question all the time. When we released Devin last year, I think half the world said this is the coolest thing I've ever seen, and then half the world said there's no way this is even possible. We can't actually have autonomous agents yet. And what's really interesting about software is there's sort of a natural gradient of complexity that already exists in the task distribution of work that has to get done. Before Cognition, at some point, I was at Tesla, and I was a researcher on the autopilot team, also trying to build sort of end-to-end autonomy, but in a self-driving setting. And that problem domain has a property that you kind of have to solve the whole thing, every time for it to be useful. Versus in coding, there's this gradient of tasks. And so the way that a lot of our customers think of Devin right now is as an infinite army of junior engineers. And so there's a category of tasks and projects that are easily addressable at that level. And then there's a set of tasks and projects that are too complex, right, for that. And so when you switch to this asynchronous agent parallel form factor, you can take a lot of the engineering toil. And we say each Devin session should be 1 day or half a day or less of work for a junior engineer. So then the big outcomes you drive with these coding agents are really about the humans becoming engineering managers of AI, and every individual contributor on the team becoming sort of this tech lead manager. And so that's the sort of shift we're seeing now. And I think our research goal is get Devin promoted to senior engineer.
Yeah, it's super interesting. It's a total shift in the way that people are working today. I'd love to hear from other people in the panel, like how you're implementing agents in your own businesses to build software and the tasks that you've found to be the best for automation and what still really needs a human in the loop today.
I think what's worth mentioning on top of this is that there's agentic software development. So we use agents to build software, but we're also building agents. And I think that's a double disruption happening at the same time. And I think it's really interesting to just see that there's a new category of software that just essentially we always wanted to write, but it was too expensive to write it. And so I'm really excited about kind of seeing this elasticity of the software market. At the very low end, it's the tasks that we wanted to do, but they were just like, we couldn't prioritize them. But the other side are these like workflow automation kind of tasks that used to be very, very difficult to program, and people would hate it and wouldn't do it because there was all these like special cases, and even just defining all of that would have been so much work. And now what you do, and that's essentially the same way how these advanced coding agents work, is that at the heart you have the LLM, and it's pretty smart, and you can give it additional smarts about your business, and then you give it a set of tools like you would give an employee. And then so the software can essentially in an emergent way figure out what to do and can help you build things. And so now you can write software that you weren't able to write. And so I'm pretty convinced that we're just going to write more software because there's more things that we can actually automate and we couldn't in the past.
I also think that maybe they're like two separate problems. I completely agree that at this point, these agents can do things that like junior engineers can do. But this is for two reasons. First of all, the duration of tasks that they can actually complete autonomously, and also whether they have the context. And a really important problem is that even when a human engineer comes in a team, right? For the first couple of months or weeks, depending on the size of the team, it's all about gathering the context and understanding how to do things. And this is something that currently our agents don't have. And this is one of the problems that at Reflection are really thinking about. How can you just provide all the context to these agents so that they can actually autonomously deliver on the tasks? And if you do that, then you realize that they're actually much more capable than otherwise you'd think they are.
Anything to add from you, Jason? Or
I mean, I think it's always odd when you have a panel that looks like this where we're building the tools that we use ourselves. And I would say that, at Poolside, we're building foundation models, obviously. We're building the agents and we're building applications. But a lot of what we do internally and how we use Poolside to build Poolside is just stuff that we did last year that wasn't capable of being done by our own system, and now it's capable of being done. So a good example of this is that we run outside of the platforms as a service, which are the Herokus and the Vercels and others of the world. We might run one of the largest runtime systems on the planet. And what we do is we download all of the open source code off of GitHub, and we put it in this runtime environment and make it run. So to bootstrap that, you had humans that would do that. They would just pull down all the source code. They would figure out a way to get each one of these projects to run, et cetera. Now we just send our agent off and start downloading this. And as the build fails or as it fails to run or whatever it is, it just keeps looping. And agents, at the end of the day, can be boiled down to a smart system that knows how to use tools in a loop. And we just do this over and over again. We can get all these 10 million projects running in our environment so that we can use it for our reinforcement system. We have this thing called reinforcement learning from code execution feedback, which is how we've advanced our models so far. But that is an arduous thing to get running. That whole runtime system is hard to get running. Imagine getting every version of PHP, 8, 7, 6, every version of JavaScript and Next and React and every version of Rust and every version of whatever, but our agent just kind of off and runs and does that for us. And obviously, it's amazing. It is an unlock for that team that's doing it, but it also just kind of shows what's going to happen in the future for enterprises everywhere.
I think it's a really good point from Jason. And yeah, this idea that everyone's sort of bootstrapping their own agents, which are then recursively self-improving, it's I think a bit underappreciated because you have a lot of folks talking about, when the AGI systems are recursively self-improving, that's when it's over. But actually, I think probably to some degree everyone on this panel is using their own tools to accelerate their own internal software development lifecycle. And we're still clicking approve on the pull requests. But how long does that last? Unclear. And this is one of the reasons that software as a category is accelerating so fast when it comes to AI readiness relative to many others, as you have this super tight feedback loop. You can do the reinforcement learning from human feedback or from code execution feedback. Before working on cognition, I led machine learning at Scale AI, and we did the data pipelines for most of the foundation model labs. And it became really clear just from looking at all the data pipelines that everything was getting better, but coding was getting way better, way faster. And so there's fundamental technical reasons for that, in that you can do this automatic feedback collection versus other domains. And then there's all these product reasons too, where everyone's using their tools to self-improve. So I think we're just going to have this huge explosion in coding progress.
Yeah.
I think one aspect that's worth looking at is like, if you're in a large company like Citibank, and you wonder like, why does my project that objectively maybe should take a month take 2 years, right? Or maybe 6 months if you could. And the reason is entirely because of communication between humans in your organization, right? And so I think one thing that's still underappreciated is that there is a disruption of these processes that can have higher order of magnitude impact than making a given software engineer 30% faster, right? Because if your problem is actually that there's 2 teams and they only talk in a couple of weeks because that's when the meeting is scheduled, then it doesn't matter that the engineer is now 30% faster and is now waiting 30 minutes longer until the meeting that's in 2 weeks, right? And so I think there's getting more people involved is actually a bigger unlock for overall like enterprise and coding performance than other aspects.
I want to actually hit on this real quickly because this is a really, really good point. When I was a CTO at GitHub, people asked me all the time how I measured internal productivity of the engineering team there, assuming that we had these massively sophisticated tools. And all I said was I measured 2 things above all else. It was when we had an idea, how long it took us to get it to production, and when we had a fault in production, how long it took us to recover from that. And obviously we measured other things, but those 2 showed 2 things that were incredibly important. One is how fast we were going from idea to implementation to release, and that shows how the teams were working, how the teams were collaborating, and also internal processes. And I found that if we can optimize at that meta level, you can optimize for the individual along the way better than if you optimize for the individual and get the meta level all at once. And people get confused by that because they think I want to get my developers 100% more productive, my organization will be however much more productive. I think it works the opposite way.
Yeah, it's a super interesting point. One of the things that comes from talking about this and the change is like, that comes up, people are like, oh, no one's going to have a job anymore, AI is going to do everything. How do you think about engineers in the future? Is your view that there'll be more engineers, less engineers, or will they just be different engineers?
Which one of us wants to take that one first?
I would be curious if there's any spicy disagreements on this question. But I think a lot of people are, software engineering is dead. Don't study computer science. It's all over for the new grads. And we have a lot of folks at Cognition who recently graduated, but they just manage teams of devins. It's just sort of the nature of the job has changed, where you have so much more engineering leverage per person, but the supply side has always been the one that's constrained in software. There's so much more software to build than there is software that exists. And I think if you look back to the history of software engineering, every increase in the level of abstraction at which we can tell our computers what to do has been an order of magnitude increase in the number of what we call software engineers. So I think there will probably be some debates in the future of, is that job even called software engineering anymore? Because it's going to look so different in a lot of ways. But if you really think of software engineering, the essence of it is just telling your computer what you want it to do. We'll have orders of magnitude more people doing that in the future than the present, I would guess.
Yeah, I think maybe, I'm not sure it's a spicy take, but I think the impact of these tools on engineers is almost like a bimodal distribution, where the people who are most impacted are the best and the weakest. And And I think there's a huge opportunity for new folks. But so one thing we're seeing is that your most high-power engineers are the ones that benefit the most, because the skills that you learn if you lead engineering teams over time, where like your code reviews are really important, how you manage your time, how you delegate work. That's what you do now, right? Like there's just more people who can help you because they're the agents. And then on the other side of the equation, if you don't have as many skills yet, these things can really up-level you. But the reality is, if you are like a software engineer with like 20 years of experience, it's a career change now. Like you're doing something else. And if you are, if you're 20, you're just coming out of college, you're AI native, you're growing up, you know how to use Devin, and you've never done anything else, you might be a much more valuable employee than someone who, is kind of has to get out of their groove and learn how to do the new things.
I mean, I feel like the way I see it is that software is bound by complexity. So like if we can have another layer of abstraction, then we can have like a lot more software. And I think there's like so many more things that we can do. And as like the cost of software drops because of agents, then it can actually like be embedded and touch like a wider part of like what we do as a society. So I think that kind of like going back to what Russell was saying, I think that like I'm not sure whether the job will look like what we call software engineer today, but it's definitely going to be someone who just, decides that a problem needs to be solved and then coordinates all these agents to ensure that like the problem is actually solved. So it's more about like thinking what are the problems that need to be solved and just ensuring that you can coordinate and have the agents solve it for you.
I don't think this is even a question at this point. I think that this panel has already kind of demonstrated the thinking that is here for people who are building this, which is really straightforward, which is the number of people who have access to creation is going to skyrocket. The number of people who care about like a specific piece of code or a line of code is likely going to decrease. The number of human developers that touch that line of code is probably going to hit the floor. And what's going to happen over time is whether you call 100 million developers currently that exist on the planet, and what they do, the task orientation is about to change dramatically. And so if you want to think about it this way, the number of lines of code that the world will produce is going to skyrocket. The number of human developers that touch those lines of code is going to decrease. If we have 100 million human developers on the planet, we're probably having trillions of agents and robots that are running around doing various tasks. It's just a pure graph at that point about what's going to happen. So this is also why when you look at where we are in the moment versus what's going to happen over the next couple of years, understand that everything is about to change in terms of the way things get refactored. But I think the prime one is going to be the interface that developers interact with the systems. Right now, again, developers sit in front of an IDE of some shape or form, but that won't be what's going to happen in the future. In fact, I think the IDE completely collapses. I think it goes away, and you basically have some sort of a task manager for agents and outputs.
Yeah, it's super interesting. Like, for those of you in the audience that don't know, the IDE is the development environment where everyone writes code in all day. But it's actually a perfect segue, Malte. I actually would love you to talk a little bit about like when you launched v0.dev, what that is, and how that's changed the way that normal people can interact and build applications. And would also be interested, Russell, to get your opinion of where you're seeing people come in. And I use Devin all the time to show people how you can build a Pong app on a phone, because you can do it in a couple of minutes, and it's a really powerful example. So I'd love to segue into how normal people have started with v0 and what you're seeing, and hear from others as well.
Yeah, so v0, which you can try out now on your phone, v0.dev, is a tool that you can think of as ChatGPT, but instead of answering a question, it builds you an app. And that can be used in the software development lifecycle as a tool to get you started. That's where the name comes from, the v0, the first version of your software. But we are seeing product market fit in very, very unexpected ways across lots and lots of use cases. So one very, very emerging category is the one of personal software. So just like Devin helps you do the things from your backlog that you might have not done, v0 makes you build applications that you wouldn't have dreamed of. I'm not sure how much you love your BI tools for doing analytics. One of the use cases that v0 is incredible at is taking a sample of your data, giving it the schema of your backend, and tell it, make me a tool for visualizing my data. And because it sees both the schema and the sample of the data, it understands the semantics of what's actually going on, and it's just going to, in 3 minutes, build you a tool that you can use for the rest of your life to understand how your company works. And that's just, again, like a tool that previously, I mean, maybe you wanted to have it, but you might have, getting that into some like workflow where someone built it for you and you have to explain to them what you want and so forth, right? Like that just wouldn't have been written. I think in a similar way, I think there's going to be a major disruption of all the large, like standard enterprise software vendors. You always made the compromise of saying, okay, it's best in class, and I couldn't afford making it myself, and so I live with what I get, and I'm going to customize it for my business. In the future, no one's going to make that choice because you're going to make the software that's actually good for running your business.
There's definitely some spicy arguments around shadow IT that people at our firm would push back on.
It is a really interesting question of like sort of what happens to sort of software incumbents, and then how does software development change as a result. One thing that's becoming super clear from where we sit is that technical switching costs are just going way, way down. And so to the extent there's an incumbent that, the strength of the business is on how hard it is to migrate your infrastructure off of them, that should go tremendously down as a switching cost. And so there's going to be a lot more competition among existing software providers and a lot easier migration between them. And we see this happening on both ends right now, where we have customers who are trying to get rid of their legacy systems much more easily now with Devin, because the switching costs are so much lower when you sort of farm out all the work to this army of agents. And then we also see software vendors who want their software to be switched to. And so you have this dramatic acceleration in many existing software businesses where now, the number one barrier to adoption is getting way easier. And I think the point that Jason made of, the future of software engineering maybe looking less like an IDE and more like commanding this army of agents is exactly right. And what's really exciting for us is that the right user experience for that future, it really changes as a function of the intelligence of the underlying systems. And so there's not kind of one perfect static solution to build. It's we're constantly reevaluating what is the right interface for Devin, for software, because as you get these more intelligent systems, you can delegate more, you can run more in parallel, you can have faster feedback loops. And I think we're in for a very exciting time to be a software engineer.
Yeah, super interesting. One last one before we go to audience questions. Ioannis, what's one concept, and also I know a lot of you are also doing AI research, so please jump in, but what's one concept from frontier AI research that you think people aren't paying enough attention to and should be today?
Yeah, that's a great question. I think that what we've actually seen in the past few years is getting closer to human level performance across like a series of different capabilities and different tasks. So kind of like the same for software development, but kind of like start with ChatGPT, you would give like human-like responses. With RLHF, you would just train models to based on like feedback by humans. But in my experience, before start reflection, I was one of the lead engineers at like AlphaGo and AlphaZero in DeepMind, where we were building these super intelligent coding agents. And one thing about reinforcement learning is that these methods ensure that you can take a model, you can take a system and just make it super intelligent. Just like make it significantly more powerful than what the best humans can do. And when you apply that to a real world problem like coding, like the possibilities are like really kind of infinite. So in the future, we'll be seeing software developers that are actually not just like better than your average human, but are actually better than your best human. And kind of like having systems that operate at this level of capability will just like really change the way we think about software.
Super helpful.
Oh, I was going to say that I couldn't agree more with that one, mostly because I would have said 2 years ago it would have been reinforcement learning is the thing that people are sleeping on. Obviously, I think the world's woken up to this, but sitting next to Ioannis over here because is always fun because we patterned reinforcement learning from code execution feedback at a meta level after what the lessons of AlphaGo. So 1, thank you. 2, amazing. And 3, it shows what's going to happen, I think, in that space. And this is why software, I think, is the first domain that exhibits human level intelligence. It's the one that we're going to break through first.
Absolutely.
Yeah, I think it has big implications on the algorithms sort of we use to improve these systems, but it also has implications on sort of how enterprises are organized and how the work is structured. Because if you look at what's happened in machine learning research, the moment you can crisply define a benchmark, that benchmark gets saturated in 6 months now. And so it's if you sort of look at the curves of how fast these models or systems go from subhuman to superhuman performance, they just keep getting steeper and steeper and steeper, and they're almost sort of vertical lines now. And most of the work is actually codifying and specifying precisely what you're measuring. And so we think this is probably going to start happening inside companies too, where the moment you can take a sort of set of tasks or a set of outcomes and crisply measure, here's what success looks like, and you do that in a way that's accessible to an automated feedback loop for reinforcement learning, that should be very solvable. And so I think more of the enterprise actually gets structured around almost how we do RL benchmarks in academia.
Super interesting. I want to say we've got a few minutes for audience questions, if there is any.
Thank you. So with the frontier model companies like Anthropic and OpenAI all coming into the application layer, how do you guys think about the differentiation across, potentially working? I know some of you have frontier models, but some of you might be working with the LLM. So how do you think about differentiation from their application layer?
I can take this. I think I'm very convinced that almost all of the value is in the layer on top of the LLM, while we are seeing strong commoditization of the underlying models, right? So you mentioned OpenAI, Anthropic, Google Gemini, right? On the open source side, there's an exciting work happening. So there is a lockstep advancement, and you can ride that wave, right? And at the same time, there is very, very strong differentiation in the tooling above. So I think there's a really, there's so much value in the layer you add on top. The other thing is my pitch would be for Vercel, our main business is running software. Everyone, I think, is in agreement that there's going to be more software. So we're very excited about running all that software.
Russell, you mentioned that the switching costs are coming down, and you mentioned MongoDB. Could you maybe talk about some maybe other sectors, maybe it's like financials or industrials, where you've seen like a case study you could just share otherwise that caught you were pleasantly surprised by?
Yeah. Also, wait, where is the question? Okay, great. Thank you. Yeah. The switching cost thing is I think super underappreciated still, because there's some cycles. People are locked into their existing contracts for a bit longer, and so it hasn't really hit in a big way that's easily measured financially yet. But we sort of see it on the inside happening in really big waves right now. So a few specific examples. One is all of the legacy COBOL in the world. A lot of people run mainframe systems that are many decades old, and you'd think, okay, they've been sort of trying to upgrade these systems for a long time, but it always is super complicated. We see COBOL to Java modernization as a shockingly big use case for Devin. But it doesn't have to be in that direction. Another really interesting example is we work with some of the largest banks in the world, and many of them run COBOL, and they actually, the biggest problem they have with COBOL is not the language itself, it's that no one there writes COBOL anymore. So they don't really understand how to maintain it. The people who wrote the systems left. And so that's the problem they have. But actually, COBOL itself, it's very fast. It's cost efficient. It's extremely performant. There's very little overhead. And so we see other banks using Devin to keep their COBOL, but maintain it better. And they actually don't want to get rid of it and go to Java. They want to now have AI agents kind of manage this. And we see this even inside our own code base. We had Devin port a performance-sensitive section of our code base from Python to C++. And most of the engineers at Cognition, they really never write C++. Devin is the main writer of C++ at Cognition, and we just don't even worry about the C++ because Devin sort of maintains that high-performance port. So it's really about increased flexibility and increased empowerment of each company to do the engineering work they want to do.
Thank you guys so much. Really appreciate all the thoughts and feedback. Everyone just put their hands together for the team up here.